In this video, we'll discuss about Profibus protocol. In 1986, by 21 company of Germany, take a project, name it as Fieldbus, and goal of that project is to implement serial bit Fieldbus. In 1989, by BMBF of German Department of Education and Research, promote a protocol, name it as Fieldbus FMS, and first used by Siemens, and that protocol can communicate between Profibus master, and that is a complex protocol. Later in 1993, another simpler and considerably faster protocol, that is called the Profibus protocol, invented. That protocol can communicate between Profibus master and their slave IOs. And now, what is Profibus DP? DP means decentralized peripheral. Okay, here you can see that this is a PLC CPU, PLC controller, and there are some IO module. Okay, you have the PLC and IO module and the sensor in the field. If that sensor is near about 100 meter, then you can connect easily with the module and the cost will be less. But think if it is more than 500 meter, then your cable cost will be very high and the signal will be dropped because it's far away from your PLC module. So this is called the central system. So if you just separate that module from the PLC CPU and install near in the sensor location about 100 meter or less than like this, then your signal will be strong of that sensor. Also the cost of that cable will be less. So you can connect that module. This is the module, this is called the distributed module, and you can connect that distributed module to PLC. Okay, and that is called the distributed system, Profibus DP system. Okay, so drawback of that system is that this is a 2-core cable with a violet sheath. So if the communication break in between that PLC controller and the remote IO system, then all of your signal will be lost. So for critical sensor, you can connect with the module with PLC CPU, and the other signal that is not more critical, you can connect to that remote IO system. Okay, and that is called the hybrid system, and that looks like this. The some signal, critical signal, you can connect with that module, and the monitoring signal and the control signal you can connect with that system. Okay, and the bus voltage of that Profibus DP cable is 5 volt, and mostly use that cable is to connect that PLC and the remote IO system. To excite or energize the system of that remote IO, you need separate power and data transmission up to 12 megabit per second. And that Profibus system is based on RS485 protocol and use 2-core cable with violet sheath. Impedance of that cable is 150 ohm, and the cable core, one is green, one is red. Okay, distance between the PLC CPU and the remote IO is 100 meter, and it can be 200 meter if you use the repeater for copper cable like this. But if you use the fiber optic cable, you can use up to 15 kilometer distance that remote IO you can use. And the megabit data rate transmission data rate will be 9.6 kilobit to 12 megabit per second. If the distance is high, your data rate will be less. You have to set like this. Okay. If you use a repeater in between PLC and the remote IO, then you can use 126 device in one single Profibus bus. If you don't use the repeater, you can use 32 device in one single Profibus network. Okay. The Profibus connector, you need a Profibus connector to connect the remote IO system to PLC system, and that remote IO system connection bus connector look like this. So to connect the device remote IO system to Profibus network, you need a bus connector. A bus connector look like this. Some bus connector has the additional port over that connector, and some of the connector has no port like this. If you have the connector look like this, this is called the service bus connector. Means you have the port to connect the remote IO system to PLC system, and also you have the port for diagnosis. By your laptop or some tools, you can connect to that port and you can diagnose the network. Okay, that has two cable entry. One is for in, another is for out. Okay, if you turn on that, this is a termination switch, this also a termination switch. If you turn on the switch, then there will be no connection with the out cable. You cannot communicate the next device with the PLC CPU. So if you turn off, then the bus connection from the PLC to that device also will go to next device by that output cable, and that connection like this. So in cable connect will be AB here also, and that is called the 1A 1B. This is a 2A 2B. 2AB is out and it is a input cable. Okay, and there are 390 ohm resistance in between data ground and 5 volt. 5 volt is pin 5, and data ground connect with the port pin 6. And line B means the red cable. Line B is called the red cable, connect with B pin, and that is the pin 3, and line A is connected with the pin 8. You can see in next slide here, you can see that B is connected with the pin 3 and A is connected with the pin 8. Okay, and it is called the 9-pin D-sub connector. Here you can see the female, their opposite side is the male connector. Okay, here you can see the switch is turned on, means the output 2A 2B is disconnected to the network. Here this one is not connected, this one also not connected, and this one is 220 ohm, that is connect with the line A line B parallel with, and there is a 4 LED to diagnose the device or connector. Thanks to Profibus to provide that system. So one LED is called the power LED. If you connect to the device and that device is powered, then power LED is green, turn on, and if the data transmission in between that slab IO and the Profibus PLC system, PLC controller, then transmission data If there is any data transmitted, then transmitted LED will blinking. And termination LED, that termination LED, this one will be glow steady if termination switch is turned on, and the error LED will glow if there is a error in that device or in that connector. Okay, there is another Profibus system. It's called the Profibus PA system. PA means process automation. Think this is a PLC controller and this is a remote IO slab device, and that has a some analog input module, and you have connected the IO, you have connected the sensor that has a 4 to 20 milliamp signal or hard that connected with the PLC module. You cannot install that remote IO system in harsh location, in hazardous location. For that case, you can use the Profibus PA system. Profibus PA system can use in hazardous area. Okay, and that looks like this. And that looks like this. If the sensor is Profibus PA system sensor, then you can connect to that Profibus PA device by the bus system. Means one cable came in the first device, then from this device connect with that system, this device, then it connect with that device. Profibus PA system cannot connect directly to the PLC controller. It needs a Profibus DP system, and this is a Profibus DP and PA converter that convert the Profibus PA to Profibus DP, and that DP can connect to PLC CPU. So thanks to Profibus DP-PA converter that we can connect the Profibus PA sensor in the PLC system. So Profibus PA is just replacement of conventional 4 to 20 milliamp sensor or hard sensor in the Profibus DP. And also there is another advantage that you don't need to use the separate power to energize the sensor. So by this bus cable, 2-core cable, you can give the power to that device. Also the data transmission will be in same 2-core cable. So bus voltage will be 24 volt supply from that Profibus DP-PA converter. Does not require separate excitation power to excite the sensor, and can be used in hazardous area. Data transmission rate is 31.25 kilobit per second, and the cabling will be safe because it will just first cable come here, then it will go to here, then it will go to here. But if you connect as a 4 to 20 milliamp signal, you have to cabling from each device to PLC module.